Hello again, Algebra 2 class. We are, in this video, going to look at a few more examples of converting exponential equations into logarithmic form. And then we're also going to go in the other direction and take some logarithmic equations and turn them back into exponential equations. So if we look at our first example here, we have 5 squared equals 25. We want to use our conversion form from down here that we remember from the first video to convert this exponential equation into a logarithmic equation. Now we're going to remember that we have to identify our base, our given value on the other side, and our exponent, and put them into their correct positions in the logarithmic equation. So if we have 5 squared equals 25, we can quickly identify that our base is 5. Right? That's the thing that is down in the bottom part of the exponential expression. So this is going to be log base 5. Right? The base of your exponent and the base of the log will always match. We then keep going and remember that that given value on the other side of the equation becomes the argument of our log function. So we're going to have log base 5 of 25 equals, when we have value of the log, what we get on the other side is the exponent. So our exponent in this case is 2. We can use a similar strategy over here. We have a negative exponent this time, but that doesn't really change anything. Our base in this case is 3, so we're going to have log base 3 of 1/9, right? The given value from the other side is going to become the argument of our log. So log base 3 of 1/9 equals the exponent, which in this case is negative 2. Moving on, we have a variable exponent this time, but that's still okay. Our base of our exponent is 4, so that's also going to be the base of our log. So we have log base 4 of 64 equals, in this case we don't know the exponent, right? It is just that x value, but it's still always the exponent that goes on the right side. Last one, we have 12 to the 0 equals 1. Well, our base is that 12, so we have log base 12 of, the given value on the other side is 1, equals 0. Right, so log base 12 of 1 equals 0. Moving on and looking at going the other direction, right, we still have to pick out the different pieces. So if the base of our log is 4, that means that is also the base of our exponent. So the base of our exponential expression is 4 as well. Our exponent, remember, is the stuff that's on the right side here in the log, is going to also be our exponent in the exponential equation. So that means we have 4 squared, or 4 to the second, equals 16, right? That given value that is the argument of our log becomes the right side of our exponential equation. We can do the same thing over here. The base of our log is 2, so that our base of our exponent will also be 2. The exponent, which comes from the right side, is negative 3, and the argument, which is 1/8, I know it's a little hard to see there, is going to become our right side of the equation. All right, so we can convert this log into this exponential. 2 to the negative 3 equals 1/8. Log base 5 of 125. Well, our base, that 5, becomes the base of our exponent. In this case, our exponent, which comes from the other side, is that x, and the argument becomes our given value. So that's 5 raised to the x equals 125. For our last one up here, our base is k this time. That's okay though, we can still use it. K raised to the, well, our exponent comes from the right side, so k raised to the m equals 11. Right, our base comes from the base of our log, our exponent comes from the right side, or rather the side without the log, and the argument becomes our given value.